Quick intro for myself. I'm a senior developer advocate at HashiCorp, where I focus on infrastructure and orchestration tooling. I like to say that I teach people best practices with our tools, but I don't get called when stuff breaks, which is, it's like site reliability engineering, but the relaxed version of it. So it's great. Which gives me time to do stuff like write a book. I wrote the Terraform Cookbook, which, if you're into Terraform, is a great book. If you're not into Terraform, not the right book for you. I'm at Kerim Satirli pretty much everywhere, so if you have any thoughts about this talk or chocolate cake recipes, I will take them. Any criticism you can send to Patrick. Patrick personally, not anyone else. So, jokes aside, I like to break up the energy a little bit, break up the room and the tension a little bit, because it is hard being here at 9 a.m. The queues for the coffee were hard. And then you get faced with the harsh reality, which is we're here, every one of us has at least one connected device. In my case, I've got a laptop, I've got an iPad, a watch, and my phone. So that's 4 connected devices, and as Ursula von der Leyen told us, everything that's connected can be hacked. And who here has seen War Games, 1984? Beautiful. So you know that no system can ever be secure, right? And that's where it ends. We could just give up at this point and go, you know what, it's not going to happen. But of course, there's vendors that will sell you the solution that will always work and will always keep you secure. The reality is that is not the reality. So let's dive into this. Ursula von der Leyen shared this anecdote with us and followed it up with a little battle cry, which is, we cannot have 27 member states all coming up with their own regulations, all coming up with their own ideas. Countries want to do that because they understand their people, they understand their organizations better, but we're part of the European Union. So you can't do that. You have to have something that works in a sensible way, right? Many of us here will use something like Azure. There's not currently an Azure data center in Austria, except if you include the points of presence for the CDN. Same with Amazon. So that means our data, at the very least, will go from Austria to Germany, if you choose to use the Frankfurt zone. If you're choosing any of the other zones, you might not be in the European Union. You might be somewhere else. And that does eventually create a problem, because I, as an individual, want my data to be safe. I want my kids' data to be safe. I don't want random stuff ending up in a place or country where I have zero control and no legal protection. So the European Union, after about 6 different attempts before, came up with a cyber defense policy. And as an engineer, I find this whole process very entertaining, because if you look at shipping deadlines for engineers and how the European Union ships regulations, man, I'm never going to have a project manager that will give me shit about missing deadlines again, because I'll just point to what the EU does. So, as Patrick mentioned, I work for HashiCorp, an IBM company. So our lawyers wanted us to say one important thing. This talk does not constitute legal advice. I cannot save you about 400 euros an hour by telling you all these things. Your situation is individual to your company, individual to your region, and everything you learn here is what I've learned. I'm sharing my knowledge with you, but you cannot go in front of a judge and say, well, he said that. You can say that, but I will just point to this slide. It's going to be slide 6 on the export. There's also another important thing. These regulations are always up to interpretation. That means every time this stuff goes into effect, enters into force, as the official term is, we have people or organizations that do it wrong, not necessarily on purpose. Sometimes these regulations are hard to understand. The CRA, the Cyber Resilience Act alone, the main document is about 70, 80 pages. That's excluding all the supporting legalese. Add in the NIS2, which is about the same size. We're talking lots and lots of interpretation. This is not like a question of like, is the dress green or blue? This is more like, did you commit something, or did you leak data based on that definition or not? So some companies are going to make mistakes. Some companies will get called out for that. Some, if they keep making mistakes, will get fined for it. And that's great for all the other companies because we can learn from that. Once you have somebody who messed up, unintentionally or intentionally, we'll find ourselves in a situation where we can learn from that and build stronger controls. So there's guaranteed going to be stuff that I tell you today that 2 years from now will be interpreted differently. With all that joyful stuff out of the way, let's talk about a few important terms. I'm going to mostly use the abbreviations because otherwise we're going to be spending about 15 minutes more to not use the acronyms. So CRA, the Cyber Resilience Act, entered into force last year, December. The DORA, the Digital Operations Resiliency Act, primarily for banks, fintechs, anyone with a financial product, entered into force in 2022. Of course, the GDPR, which we all love to ignore for the past 10 years, or 9 years. Well, we've been ignoring it before that as well, so it doesn't matter. And the NIS2, 2023-ish. But all of these have timelines, which is why there's a circa for all of them. So, all words make sense so far, right? If not, that's cool. I was as confused as you were at this point. And to make it easier, I'd love to confuse you a little more. 10th of December last year, about a week after Niklaus came to Villach, we had the CRA entry into force, which means it was published about, 20 days earlier in the official journal of the European Union, and then it is now something that you can legally refer to. And it's great. The only deadline in there is 3 years later, 2027, 11th of December, is when all the obligations apply in full. Great, right? We've got plenty of time. Sadly, not enough time, because if I'm looking around here, nobody of you is going to be retired by that date, so might want to pay attention. Then, of course, next year in June is when we actually find out who can tell us if we're doing it the right way. And you might wonder, well, how does a law or a regulation enter into force without knowing who can tell us if we're doing it the right way? And that is a great question, and you should definitely write your European representative and ask that. The answer I got, I did actually write because I was very confused. How can you make a law without telling me who can identify whether I'm screwing up? The answer to that is, this is how the European Union does its work. And I'm waiting for that moment where I can use that in an email. This is how I do work. I will tell you afterwards what the deadline was and how I'm going to do it. But a year from now is when you really have to have something to show, which is being able to report vulnerabilities, actively exploited vulnerabilities. So if your system, if your system has a 0 day that is not actually being used, and you're aware of it, you don't need to report it. Might want to fix it, just being a good human and all, but you don't have to report it. This is, parts of this law are like a chihuahua, makes a lot of noise, doesn't have a lot of bite. Same with the interpretation of incidents. You only have to report severe ones. So if one person's PII gets leaked, that is not considered a severe incident unless your platform actually has only one user. There's a certain percentage you need to hit. Now, we're engineers, we want to do the right thing most of the time, which is close JIRA tickets. So let's look at this in a way that's slightly more useful, hopefully. We're 270 days from the entry into force, about 9 months. And we're about 270 days from knowing who can tell us what to do. We're just a year out from being able to report vulnerabilities, and to be able to report vulnerabilities there are certain requirements, of course. We need to know where our data comes from, where our data went, lots of other stuff that we'll talk about later. So it's good to keep that in mind. A year is not a lot of time. You've got about 200 working days because we all know we take about a month off in December. Plus, like your summer vacation and everything, which next year is going to be canceled because you have to have this stuff ready on the 11th of September. So that only leaves one. 825 days sounds absolutely amazing. I hope to not be in a specialty that requires knowing anything about this at that point, but somehow my daughter does not want to pay me to hang out with her the whole day. So I might have to have a real job at that point. And the worst part is, this comes about a week after Campusnacht. So you can't even have a lot of fun and blame it on the campus. All right, palate cleanser. We spend about, what is it at this point, almost 15 minutes talking about legal frameworks and all the other joyful stuff that goes with it. So please feast your mind on a beautiful, serene beach. This is my wallpaper. This is a video I shot to relax when you're looking at legal frameworks. And I hope it helps you as much as it helped me. These are real people down there, and they did not consent to being pictured here, but that's okay, because you cannot identify them, and GDPR does not protect them that way. So, I think that's enough of the beach. Let me switch to this one real quick. I want to talk about 10 lessons that we can take away from this. Now, we all love, I'm going to assume we all love building cool stuff. And a lot of times, especially as you get further on in your career, you see the infrastructure for you. You see the system in front of you. You know what you have to build. And you can sketch it out, throw it into, if you're that kind of person, throw it into Figma. You can throw it into a mermaid diagram. You can just code it, maybe even use an AI agent and give a few sentences to get your whole infrastructure, and that's great. But before, when it was okay to just do deployments that way, we now have to design our deployments in a slightly different way. We cannot start by deploying infrastructure and then think about the legal ramifications. Auditors will crawl up your system to ensure that you're doing the right thing to protect the citizens of the union. Data residency regulations, like actually knowing where your data goes. Does it touch a different cloud? Even unintentionally, all of these are things that will eventually affect how you deploy your system. And then come the fun parts. We talked about this briefly yesterday in the workshop. Imagine you have a Power BI system running in Azure. You're pulling in data from an S3 bucket. That S3 bucket, purely by accident, happens to be in US East 1, which, well, if your geography sucks, is not in the European Union. If somebody finds out about that, and of course you will have to have the logs to prove this, that it didn't happen, but you can't, these bad transfers will trigger regulatory action. And that's where those mistakes start. The joy about that is the first time it happens, unless you're doing super egregious stuff, it's a slap on the fingers. But even then, re-architecting is not easy. So the way we're going to solve this is we're going to classify all of our data flows. As an engineer, there's nothing more joyful than thinking about like, oh, well, so I'm saving this file to S3, but I'm doing a cross-regional replication. What tool do I even use to map this out? Doesn't matter. Even a napkin is better than nothing. Being aware of where your data goes, creating a data transfer impact assessment, a DTIA, those are the things that you want to have. They sound boring. The templates for them are incredibly joyful 16-page documents that you don't want to ever look at again after you've seen them the first time. But once you know where your data flows, you actually worked on building a more resilient system, even from an SRE perspective, because once you know where everything goes, things get a lot easier. And then, of course, build your system differently. Do not allow deployments outside the European Union. I work for a company that makes an infrastructure as code tool called Terraform. In Terraform, something like this, pinning to the default locations that are inside the European Union, is a 2-line change in your code. doesn't matter what tool you use, enforce stuff like this through code. But also be aware of one thing. If you've used a cloud, you know anything outside the European Union is drastically cheaper than inside the European Union. And sometimes that motivates people to just store stuff in the cheapest location. It doesn't get cheaper than storing it in the EU and not having to pay massive fines. So don't save the money in the beginning just to have to pay it down later to the EU or to your local watchdog. Quick show of hands, who here uses long-running credentials for their services? There's no shame, we do not judge. Thank you for raising your hand, I appreciate you. It is very hard. We've all been there. It's great to see so many people not make that mistake. The reality is we all have colleagues that make that mistake. And it's frustrating, right? We want to do the right thing, but sometimes doing the right thing is hard, and it gets even harder if you have to have credentials that work from one cloud into another. But by standardizing these things, you can meet one of the regulation requirements, which is you're able to prove where your systems go, where the people who have access to your systems go and how they access said data. It also brings you into a position to be able to say our data access policy in AWS is the same as our data access policy in Azure, same being the same kind of access rights, not able to delete versions, stuff like that. And once you've unified all of this, this also means that when my colleague finally leaves, I can do a one-click delete of their profile versus finding out that 17 months after he decides to come back to the company because we were the better choice than the company went to in the meantime, his account is still around. It's a fun story to tell. It's not a fun story to tell to your auditors. So, of course, DevOps Days has been around for 15 years, 16 years at this point. We've been talking about this literally every year. Implement least privilege IAM. I'm not going to ask you to promise me that because we all know that's very, very hard. But even if you get there halfway, that's still 50% better than your previous option. But what I would like all of you to think about is implementing more short-lived credentials. Build stuff that expires quickly, build stuff that rotates, because you are building stuff that is more secure. And it also forces you to build role catalogs, which will give you better role-based access control. Much better. But of course, none of this comes without cost. Building a system that can support secrets rotation, dealing with all those legacy secrets, dealing with all the people who maintain secrets in a Git encrypted, Git crypt encrypted file, and moving that into a system, there is engineering effort involved with that. It's a lot of fun to solve that problem, but it is not without cost. Which brings us to the next part. You're encrypting stuff. You have keys, hopefully. You have probably somewhere in your system, you've at least committed one of those keys to Git. And that's no problem, right? Because your GitHub repository is private until somebody accidentally copies that key somewhere else. We joked about this in our workshop yesterday. If you leak your credentials or certain private keys to GitHub, the GitHub firehose gets scanned by Snyk, by Datadog, by a couple of other companies. You will get an email. So will your security contact. If you're the security contact of your company, you should ask yourself, why am I getting this email twice? Because maybe I need to train up. If you're getting this, if your security contact is getting this email and you are the reason that they're getting this email, boy, it's a good time to take some out of office time. And then come back with a refreshed mind and figure out why this happened. Bigger thing here is this. Back in the day, it was super fine to just have a single key for everything, right? At this point, one, we have the technical capabilities. Two, we also have the expectation that we use client-specific keys. So the stuff I encrypt for client number one, will not be encrypted with the same key as I use for client number 2. Those keys can be derivative of a master key, that's totally fine. But they cannot use the same key, and they should not use the same key. And there's also the other thing. If we use the same key for everyone, how do I revoke it without affecting everyone? Build systems that allow you to cycle your keys in an easy way. And then plan for the key compromise. We're all humans. We all have colleagues that make these mistakes. None of us here, of course. I mean, it shows from the simple fact that you're here on a Saturday at 9:30. But we all know those people that have done this. And it's hard, because at that point you have to rotate your keys, you have to figure out who to involve. I worked at a company where revoking and rotating our keys required 3 people to unlock 3 different safes to get the one-time tokens that we had attached. Now, all those 3 safes were stored right next to each other, so if the building weren't done, that was still a stupid idea. But it made for a very secure system. You could not screw up and let it just pass by. People were involved in that. So you have to document that kind of stuff. A key rotation ceremony is very much a ceremony, except there's very little calm and a lot of coffee. But it's still important. And especially in today's age, you have to log everything. Audit logs, access logs, rotation logs, lifetime of the key. We like to monitor. So let's say a key has to have a max lifetime of 32 days, a month plus a day, a long month plus a day. We will usually revoke it around 27 days and rotate it. We try to monitor that because sometimes our automated tooling might fail on the 27th, and you want to figure out why. So by knowing, is our rotation actually happening, we can prove to our auditors that we are making a concerted effort for things to work. But of course, with all this joyful stuff and security hardware, like hardware security modules, key management services, there's a certain cost attached to it. You can save a lot of this by using virtual HSMs for testing purposes, but the H in HSM stands for hardware. So if you use something like soft HSM, which is a software application, you are not going to get the same benefits. Use it for testing, don't use it for production. And then think about the re-encryption cost. Changing a key is easy. Having to re-encrypt data is a lot harder. And so as you're logging everything, what you're creating is a lot of evidence. All that evidence is critical. It must be immutable, like your releases should be. It must be something that you can prove was generated at the right time, and not just by somebody typing in the correct spacings into a log file. And you must be able to prove that these things contain all the data. There's a lot of expectation here. The good thing is, most modern tools in this space will just give you the right format. So there's not a lot that you have to do. As you're building these evidence bundles, make sure you sample them. Make sure you check what's in there. Work with your legal team. Work with, I guess, at this point, I'd go with somebody like PwC or Deloitte to verify that the stuff I have in the evidence bundle is actually stuff that should be in there, that I'm not missing massive parts. The EU also has a couple of PDFs of what they expect to be in there, but it's a good idea to eventually test it before stuff goes wrong. And of course, as you're collecting lots and lots of logs, you want to develop retention guidelines. How long are we going to keep this stuff? What are we going to do with this stuff? Are we moving it to cold storage after 2 years? Are we actually deleting it after 7 years? And these are fun problems to think about from an engineering perspective, because after 7 years, are we okay to move it outside the European Union? Should we keep it here? The storage and analytical cost of it all, analytics cost of it all, does go up. And it has a significant impact, especially as your system runs for longer. So it's worth to keep that in mind. Probably my favorite one is really guidelines are not guardrails. I can tell you to not walk off this stage because you'll have a bad experience, but unless you have something like a handrail, there's nothing that prevents me from walking off. We have a guideline here. Patrick said, don't walk down because you'll fall. And I was like, well, I can definitely jump. You can until, your body decides to not work with you. And that's always a bad time. So, in a system that is being used, humans are usually involved. Humans introduce drift. Systems introduce drift. And drift is risk, and risk causes drama, and drama causes JIRA issues. I don't like any of those. So what we like to do is make sure that we have policies in place that allow us to basically limit everything that we're doing. Who here has ever used something like a linting tool, like CSS-lint or JS-lint? All right, so the first time you used it, did it break your heart by telling you how shitty your code was? I mean, the reality is it was probably right? I hate to admit it, like the first time I look at my code, I'm like, no, come on. I did not have 536 issues that need to be fixed. I used the wrong repository on this. It's fine. But the reality is, if you have any kind of quality assurance tool, it will help you create stronger systems. It will help you create stronger code. And that's what matters. Plus, it's another one of those things on an auditor's checklist where they can say, well, yes, look, this is what we need, and this is what we're expecting. Shift, that's scanning all the way to the left. I need to be able, on my machine, to see what's going on and what might fail even before I deploy it, because that way I can make corrections either by discussing the policy and making sure that we're aware of what's going on, or by making sure that, well, shit, I should not actually be deploying 14 game servers when it's meant to be a simple web server. All of this is hard, but it's a fun engineering challenge. And that's what you have to keep in mind as you slog through all of these regulations. But anytime you introduce gates like this, you will have friction. You will have friction between developers and operations. Oh, wait, no, we solved that because we have DevOps and we all work together. Well, there's still security. They're always kind of mean. Well, wait, we kind of have to work together on this. I think that's the key takeaway here. I've purposely excluded biz from that because to me it's DevSecOps and not DevBizOpsSec something. Because ultimately this is a technical problem more so than a business development problem. What we do here has to meet the EU regulations before it can meet the sales wish list. Which brings us to lesson 6. Being able to prove what we did is part of our border protection, it's part of our border control. We need to be able to say this binary we ship to a customer contains X, Y, and Z and nothing else. The EU has an expectation that we design systems that are secure by design. Sure. My definition of secure by design is going to be very different than everyone else's definition by design, by which I don't mean mine is better. It's just we all look at this through different lenses. But there's one thing that we've all definitely done. We've released something as a Git tag and then realized something was missing and we just revoked it. Because nobody needs to see that mistake, right? From our colleague, not from ourselves. There's a problem with that, because once you revoke a release, a system might break. You are losing a chain of custody and proof of custody that you're just like creating this little black hole in this timeline. That is no longer okay. You need to sign your artifacts, have software bills of materials. All of this is super simple. Plenty of open source tools, the Linux Foundation, the CNCF, they have a lot of stuff that you can get started with today and have all of this signed by Monday and then get your promotion on Tuesday. But deploying this stuff does come at a cost. Just like storing extra logs, storing all of this stuff also has a little extra that you need to plan for. And then comes the fun part, right? We're using multiple clouds. How do we actually deal with incidents that affect multiple clouds? Well, I come from a town that has an amazing hockey team. It's called the VSV. We never win, but that's because lately it's been very warm. But we still train. We still train like we should be winning. And maybe one day we will again. For hockey, you don't have strict timelines. The EU on the other side came up with timelines where I was like, did you just like select the next option in the hour dropdown every time? You get 24 hours for an early warning. That is not 24 business hours, also known as 3 business days. That is 24 real-time hours. If it takes you 10 hours to notify that a system was leaking data, congrats, you now have 14 hours. 72 hours to send out a notification, which is great, because your legal team will need at least a full business day to actually figure out what can we say and what should we say. And then in 30 days, you need to have a final report ready. These are wildly unrealistic deadlines, and people are going to screw this up. Organizations are going to screw this up. But if you can show that you're working towards that, it does make a difference. One way you can work on this is by training your incident commanders. Tools like PagerDuty, Incident.io, they all make it so much easier to surface the right data during an incident. So that's something you have to think about. Where do I put my data? How can I make sure my data gets into the right hands? How can I combine the data at the end as quickly as possible and make sure we have everything? A lot of these tools now employ AI that accesses your system to come up with the right reports, and that's great, because nobody has the time to actually go out and do the research for 16 hours. Not if I can have a model that's trained specifically on that to help me with that. Still, you'll need to train with this. Don't wait for the incident to come to figure out what features your tool has or does not have. You don't have to use those tools, but you probably should. For one simple reason. Being on call is draining. There's only so much coffee you can take before your doctor tells you to lay off on it. They're wrong, of course, because they don't understand the engineer lifestyle. But on-call fatigue is a real, very real thing. And one way to make sure that doesn't happen is for you to be able, as an incident commander, to step away after handing it over to another incident commander, knowing that they will be able to carry this forward. There's nothing worse than being in an incident that you're managing super well, handing it over to the next incident commander who has no frigging clue of what's happening. Because it will mean that in your mind, you will keep going. You won't get the rest that you need, and when your shift starts again, you're not going to be rested. You're not going to be able to be at your best. And the reality of all of this is we all use other people's software, other organizations' software. So your vendors, stuff like companies like HashiCorp, companies like IBM, we are part of your system. And there is risk with that, right? How do you know your vendor creates software bills of materials? How do you know the code they use is bug-free? Oftentimes, we have these expectations that we can just pull the packages from our vendor and trust them implicitly, which is great because if, as an attacker, you're able to compromise something like that, like a Red Hat satellite server or something in those areas, you can mess with a lot of systems. The reality is you cannot trust those systems implicitly. There has to be verification. And there's also a requirement that if you're using a company's software, their reporting will eventually affect your reporting. There we go. Which means ask your vendors contractually to provide you with software bills of materials, provide you with VEX files. Everything has to be agreed upon because it forces your vendor to do better. Companies want to do better, but that want stems from wanting to retain you as a customer. If no customer ever asks for it, a lot of companies are not going to offer up this option. So be sure, as you select your vendors, that you know who you are working with, how they're working, and put yourself in a situation where you are not a government contractor that uses engineers from Shanghai for the US government. That happened. It was one of the major cloud providers, and people got really upset about that because you should probably not have the US government cloud be operated by foreign nationals. But all of this also affects your procurement cycles. Every time you send a contract back with little squiggly lines, you find yourself in a situation where you're going to be able to add 3, 4 extra days to the process for every single line. And now we finally built it, right? It's running, it is there, and we're shipping data everywhere. Holy shit, that's not good. We're shipping data to the US, we're shipping data to the London zone, but that's in Europe, right? Oh wait, crap, we're supposed to be in the European Union. Okay, that's a problem. There is a certain expectation of data residency, right? If you have one of those VTech kids cameras, the pictures get stored in the cloud, you might expect that those pictures get stored in in the European Union. But the Frankfurt bucket was too expensive for VTech, so they stored their stuff in the US. And I personally did not remember consenting them storing their pictures outside the European Union. All of this, as before, will bring in cost. And sometimes cost is a good motivation for companies to say, we're not going to do the right thing. We want to do the right thing, we cannot afford it. It's a real thing. Sometimes that forces you to re-architect your systems. So, just like we said before, jurisdiction first, topology second, we have to think about the system we're building. And that's hard. We need to basically think about how are we going to approve our workflows, how are we going to build our approval workflows before we build them? How are we going to make sure that once somebody clicks OK, we're actually in a good place here? And part of that requires sometimes shipping data not via the public internet, despite that being so much easier. All of this will make it slower to deliver your system because you're thinking more, you're building more resiliency, and you're building in controls. Time to finish is just not going to be the same because it's no longer high speed, low drag. The reality is it is going to be a much more thought out process. And complex systems fail. They fail all the time. So that means you have to continuously practice your failover paths, your deletion paths, and everything. You should always expect that your containment will be breached. We've seen this in Jurassic Park. They have 15 animal handlers, and the raptors still get out. And you know what? Our systems are the same. The attack will probably not come from the outside. Many of us are not big enough to be of any interest to state-sponsored hackers from Russia and China. But we'll have disgruntled employees who picked up a USB stick, plugged it in, and oh shit, well now we're leaking AWS keys. But it's not just the internal attacks we have to be worried about. You might find yourself needing to move data out of London into Frankfurt, for example. That means you need to know where your data has been, where your data is going, and you need to prove that if you're saying that, hey, we moved everything out, no data goes through that anymore. Data portability is a hard thing. It is a very hard thing. And sometimes, as laws change, you have to say goodbye to a vendor because they cannot support you in the area that you want, in the geographical or political area. Data transfer, impact assessments, and just the lineage of your data, the proof of the chain of custody, is a hard thing to build, but it is something that you have to know because you cannot do revocations, deletions, and everything else without knowing how it goes. And of course, it's not just, well, this README says RMRF, everything in this bucket. You actually have to test this. You have to be able to commit to being able to tell people how long it will take. But of course, that is expensive. You will have duplicate data. You'll have to prove that duplicate data was deleted in all places. If you're versioning your data in your storage accounts, well, you'll have to prove that you actually cleaned up all the versions. This is not easy, but it is a good thing to work on. Mind blown, probably. Or blank, like my slide, for whatever reason, we'll get there. There we go. That's what I was looking for, thank you. Ignore the technical problems. But this is actually a good cliffhanger. What we talked about today, you might go like, well, that sounds like a legal problem. It sounds like a not me problem. The reality is, it is definitely not a them problem. It is an us problem. We're all citizens of the European Union. We work with companies in the European Union. We are the ones that affect the systems that protect these rights. And that's hard, right? That's a charge I did not sign up for. All I want to do is build cool Terraform stuff. I don't want to deal with this. But you know what the reality of this is? As you're building this, you are helping solve problems. I don't know what's going on there. That are great for your career. Because if you're able to solve this stuff consistently for your company, you're showing leadership. You can work with your colleagues on showing this leadership. You can inspire others to do better. And we'll need people that are interested in solving this, because this is a hard problem. It is not just 5 lines of code and that's it. Because if it was 5 lines of code, we wouldn't have a 71-page document with a couple hundred pages of extra stuff around it. Solve this to push your career forward. There's many, many aspects in all of this. Maybe you're interested in the storage technology of all of it. Maybe you're interested in the key revocation or the algorithms that go into actually creating those keys. Maybe you want to deep dive into cryptography. All of this are great things for your career. They will push you forward as an engineer. So helping the EU helps you. Okay, my test audience laughed at that, so. All right, that's all I have for you today. Thank you so much. You've been an amazing audience. And with that, back to Patrick.
Thank you so much. Thank you so much for your talk, Kerim.
My pleasure.
Don't run away. We have maybe some questions from the audience. Any questions for Kerim according to his talk?
Everyone's like texting with their lawyer right now, like, hey, can I ask this about our system?
Don't be shy.
Oh, I was shy. I was.
Then maybe I start. Do you have a favorite lesson? Which one was the hardest to learn?
I think the hardest one, as an engineer, like you get this like feeling in your hands, right? Like you want to hit the keyboard, you want to not like smack it, but like have your fingers hit the keyboard. You want to start coding, right? And that's okay. But the reality is we cannot just rush into it because a lot of this stuff is very hard to undo. If you have a system where everything is encrypted with a single key because you cut that corner in the beginning, that is very, very expensive to solve in the end. Take the time to think this through. And that's about it.
Thanks a lot.
My question is regarding logging. How do you log the correct way? There are so much log files, so much entries. How do you organize the log files?
Are we talking audit logs or encryption logs or all the logs?
Logs for the audit. So if anything has happened, so you have to make sure that you can say what happened and why it happened, so that you can see what happened in the log files when something happened.
So I'm going to give you my answer, which uses software that our company builds, but you can build this in other systems. We pass critical logs through Vault's transform secrets engine, which basically allows us to create proof that the log file hasn't been altered. So we push it to a sink that immediately, it's custom built stuff, that immediately runs it through a secrets management tool, which ensures that all of our stuff basically gets fingerprinted, and we store the fingerprinting logs, we store the fingerprinting logs in a system next to it. The use of that is that we can see at any point when we need to verify, is this actually trustworthy? Has this been tampered with? Being able to prove that your stuff hasn't been tampered with is obviously critical to the EU, and it's not actually that hard. Passing data through is a very quick operation. It's not fun. It does use a lot of compute, especially if you're passing a lot of data through. But it is, while it is a compute expensive process, it is not a time expensive process. So for us, that was a delay that we were able to accept. Logs get stored in multiple locations. So take an S3 bucket, cross-region replication, versioned. So that means there's always at least 2 copies of the log file. And the systems themselves retain log files, I want to say, my head said like 168 hours, so like a week, on the system as well. So we have multiple copies. So worst case, we can also compare those files to one another. Basically, what you want to do is make it harder for your attackers or anyone to alter log files without that becoming super evident. Anytime you upload access log or encryption log to your bucket again, even under the same file name, a new version will be created. That means I can now compare this to the old version and ask, well, why is it that these 10 lines are missing here? That is one of the approaches that we like to use, but this is very much a what does your company need to meet in terms of regulations kind of thing where you start building that system. But great question.
And another one?
Yes, hello. You mentioned earlier that there's like for the incident management, you have the 24 hours to report the vulnerabilities and incidents, except for the zero-day vulnerabilities, you are not obligated to report them.
When they're not actively exploited, yeah.
If they're not actively exploited, but how can you like see if they're really actively exploited? And is this like a legal, how to say it, a legal possibilities that gives the company like the legal possibilities for the backdoors?
So I like to quote one of our security engineers on that. If your system has a zero-day vulnerability, you will know, simply because it will be exploited. Because otherwise you will never know if there's a rootkit running. Generally speaking, if that kind of stuff happens, you're already in the shit. It doesn't matter if you want to report it or not, you're probably at that point already doing incident response and mitigation. Isolate those systems, disconnect them as much as possible so the attackers can no longer access them through network. If for some reason they manage to get into a serial console, go into the data center and unplug that cable. If they're managing that through your AWS account, then you have bigger problems. But the reality of all of this is, even if you're not required to actively report it, you want to actively contain it. And then work with your national cybersecurity watchdog. Like in the Netherlands, we have the National Cybersecurity Center. You could basically create an image of your EC2 instance, for example, that has all the malware on there. Give them access to it, and there's 2 things that happen. One, they'll look into this, which saves you tens of thousands of euros, because if you ask Deloitte to do the same, they're going to charge you for the hour. 2, they will come up with ways to mitigate this. Actually, 3 things happen. You get a t-shirt that says, I hacked the Dutch government and all I got was this. Which is the same t-shirt they send even if you're reporting critical vulnerabilities, but it's cool, right? The more important thing here is, if you see an issue with your instances, any kind of exploit, isolate, disconnect, and create forensic reports. If you don't know how to create those forensic reports, because it is hard to log into a system, get data off of it without altering that data. If you know SSH, anytime you log in, a log file gets updated. Have somebody else do this who knows what they're doing. Being able to show what's happening and what data is on there is absolutely critical. So basically, think of it as this way: you're seeing a body laying on the street, you know a crime has been committed, but you don't know how to retain the proof. Don't touch it, let somebody else handle it. Just make sure it's disconnected. The body.
Thanks, Kerim. Maybe a last question from the audience.
So all of this, what you talked about, sounded really overwhelming for small companies. Do you know about some tools or anything like this for small companies, how they can implement all of this stuff?
It's an interesting question to ask a vendor. Yes. So I swear I did not pay this gentleman to ask that question, but when you deploy infrastructure, anytime you codify it, and that doesn't have to be with Terraform, but it could be, you're creating a more traceable system. So for small companies, invest into codification early. Don't ever roll your own crypto. Have a tool that other companies use. That could be something like our Vault product. That could be simple things like GitHub's secrets, which is sodium-based key value encryption. All stuff like that. There's a lot out there. Azure Key Vault, Amazon Key Management Systems. They're like 50 cents a month to retain the Key Vault. And then, of course, the data that goes in there. It means that somebody else is solving encryption for you. That's a good getting started guide, or getting started point. Don't not do this because it's too overwhelming. Pick the small things, and even if your system is not of the same quality as what, like the Raiffeisenbank might have, that's okay. If you're making an effort, that already makes your system stronger. But as you get into these waters of producing software, shipping stuff across borders, shipping stuff across the EU, those regulations will apply. Find the small wins and build with them. And talk to your vendors, talk to what the community is using. All of our software is available for free. So you could use something like Vault to do the whole encryption, to do the whole key rotation with a system that has proven itself over the past 10 plus years. But apart from our system, there are plenty of tools out there that somebody else will happily manage for you that are part of the cloud you're using anyway. So use them, start there.
Thank you so much, Kerim. And maybe one last question, a private one from me. No worries. Was it already worth asking us to trigger DevOpsDays Graz?
I think so.
Thank you so much.
Thank you.